Well, hello friends and followers. So I been puttering around with this World War II radio, the Crosley BC-654a, and I was trying to get the modulation working better, so I had the radio upside down and I was looking for voltages under there. But anyway, I wanted to get the push-to-talk working. And push-to-talk means you push the microphone button in. There's the microphone there. You push the button on the side in, and the radio should transmit. So that took some doing. There's a relay inside this unit here, which is the dynamotor. It's called a PE-103a. And when the dynamotor is ready, it'll close the relay, which enables the BC-654 to transmit. So I tried to simulate that in my power supply. So my power supply that I've been working on here is always ready to go. It doesn't really have any issues with low voltage. It runs off of 112 or 117 volts AC here in the USA. That'd be 220 in Europe. And you turn this thing on and you have all the power you need. So as from my last videos, I finally put in another voltage divider to get 500 volts out of here and 500 volts into here. And I take 12 volts AC out of here and I generate 12 volts DC, and I take 6 volts center tap here and I get roughly 6 volts here to run the filaments on the transmitter. So 12 volts, I'm running the PE-104a multivibrator for the receiver, and on the 6 volts, I'm running the filaments on the transformer. And what else? The B plus 500 volts, of course, is for the transmitter. So the push-to-talk thing was rather bizarre. They have a line which goes low, so when you press the microphone, they have a line that goes low. And that line will fire the relay only if other circuits in the dynamotor or hand crank are ready to go, then you'll get transmit. So in this thing, I simply have these two relays here, and they're in parallel as far as the windings go. So when one relay fires, the other one fires. And so I'm sending 12 volts up, like or 6 volts up to the radio here. And when this microphone is ready to go, it will ground. So then the relay in this radio will fire. So this relay here with the white wires is firing the relay in the radio on push to talk when it closes. This relay with the red wires is turning on the 500 volts B plus. So why didn't I use small, cheap relays? Well, that's why. This radio, everything in this radio is like overbuilt. And I thought, well, you know, to be in the real spirit of 1944, when this thing was made, I probably want to put in some really huge relays. And so these make a lot of noise. They work. They're heavy duty relays. I'm probably only switching milliamps through these. Certainly nothing like 25 amps like they're made to do, but these relays are very solid, and they're Potter Brumfield, and they're just really great relays. So I kind of bought these on a lark. They were about $54 for both of these on eBay, but bought them. I think they're brand new. I was worried they weren't going to fit, but I found I could fit them in this bud box if one relay was kind of cornered to the other one. What's funny is they almost will hit if I put them the same way right side up. There's this little adjustment here, right here, that would hit. So anyway, I didn't want that to happen. So I have one in upside down and one in right side up. The other thing is this wire here is 500 volts from the power supply. So here, the 500 volt wire, I put that on the bottom. So this part here is not energized with 500 volts unless you're transmitting. And then indeed, that would shock you with 500 volts. So that's not real pleasant. But one of the downsides of using a old relay or an old design of a relay, I will need to paint this red and put a warning in this box for people that might open this thing up in the future. So that's about where I'm at. So to demo this thing, I can turn on the power supply here, switch in the front, just turn it on, and if all goes right, light comes on, and you don't hear any bad noises or smoke or explosions, which is a good sign. So now this thing's running. I have the radio turned off, so let's go turn the radio on. So I'll go in voice mode for the microphone. So to do that, you would want to, I select high power because I want to go high power. It has both of the final tubes on, the filaments turned on. Go to voice, and the vibrator comes on, the speaker comes on, and you've seen all this before. It's nothing magic for you. So the new magic today is I do have push to talk working. So you can grab the microphone here, and I mean, this is no big deal for a modern radio, but for this old radio, to make it work like it's supposed to on the dynamotor and on the hand crank with a power supply like this, I'm really happy. So now when I push this mic down, you'll see the relays will jam down, and they're quite noisy, but I don't care. I wanted some clunk. And then you'll see the carrier will pop up on the scope here on the RTL-SDR, and it's indeed transmitting on 3.9 megahertz. I still got a modulation problem. I have a new microphone on order here, so I'll try a new mic in this thing. It was made in 1963. This is probably like a 1942 to 44 mic. It's old, you know, it's working. I don't know if the element here is bad or the radio itself is a problem yet. I don't know. I'll try with a different mic. So for now, I want to get the PTT working. The other thing is I didn't want 500 volts in this radio all the time. And that's in case if the multi-vibrator goes out, the minus 70 volts bias to the finals go out and they'll melt. So I really didn't want any B+ in this radio unless I was trying to transmit. So that's another safety valve. And I guess that's how they did it with the hand crank generator or with the dynamotor over there. So that's about it. I'll give you a demo on the sound here, which isn't very good, but I'll turn the receive sound on here. Push to talk. Testing. 1, 2, 3. 1, 2, 3, 4, 5. Testing. 1, 2, 3. 1, 2, 3. Testing. Hello. AM test. 1, 2, 3. Testing. Push to talk. Test. So I'm really happy with the push to talk. PTT test 1, 2, 3, 1, 2, 3. Crosley BC-654a testing 1, 2, 3. So anyway, so I think that pretty much at least completes this phase of my build out of this radio. I suppose I can just run it now and make sure nothing here blows up, because this has all been a hack. I mean, it's been like, okay, just make this work just by experiment. And there's a huge voltage divider in here that's very hot. I don't like that, but that's how Heathkit built this power supply anyway. I just put another divider in here, but yeah, we'll see. And oh yeah, CW mode. So when you click the CW mode, this thing will keep the B+ on, and the key will key the relay inside this radio. So there's a TI relay inside here, the keys with the Morse. So let's try that out. Let's get this key in here with one hand. The radio is upside down, unfortunately. Okay, the key going in. There it is. And now we go to CW mode. When I go to CW, it turns on B+. And I can then use the key. Here we go. You heard it click over there. We got B+ now. If I key this thing up, it should key the light bulb there. And there it is. So you can't go real fast in this thing with CW, but it works. Well, that's pretty cool. That's how that works. Go back to voice now. There's voice, relays are off. B+ is off. Now when I key with voice here, this won't have any effect. But if I key the mic, I should get about 1/4 of the power out of this thing, which is about 7 watts. I should get a very dim bulb here. Let's see if I can get the bulb to go. Key the mic. Yep, there it is. Upward modulation. So there's no modulation really, so it doesn't really affect the bulb because I still got some problems with the modulation. Anyway, that's my demo on the BC-654a. I still gotta get the antenna wire connected up correctly. There's probably people talking on here, but I could probably try and talk to people tonight if there's people on here on the AMI net. I might try that. If I do, I'll document it. Okay, that's about it. It's still receiving. Just no antenna. Thanks for watching. Have a great day.